In this video, I will discuss a bit how to find the change in velocity if you have the acceleration and the time. Now, this process, even though it is similar to the one that I explained in the video, how to find the displacement from the velocity time graph, even though that this process is the same as that one, you may find this to be a little bit more complicated. Okay, let me start with a simple example. Let's say that I have an object that has an acceleration of 2 meters per second squared, and let's say that this is constant. Okay, so I have a constant acceleration. Now, if the motion takes place from 0 to 2 seconds, then I can use the units of this quantity to predict what the velocity will be at the end of the second. So if I start from an initial velocity of 0, I start at rest, then after 1 second I will have a velocity of 2 meters per second. How do I know that? This quantity is telling me that for every second, the velocity increases by 2 meters per second. Since I go from 0 to 1 and then from 1 to 2, I have 2 seconds. For every second, my velocity increases by 2 meters per second. So I started 0 meters per second. After 1 second, I went to 2 meters per second. After 2 seconds, I ended up with a velocity of 4 meters per second. Now, you can get this result simply by multiplying the 2 by 2. 2 seconds, 2 meters per second over second squared, you get a 4 meters per second. Let's do this in a graphical way. So let's say I have the time in seconds and the acceleration, and the units are meters per second squared. Okay, let's say we have, as we said before, this is 1, this is 2, this is 3, and so on. We have an acceleration of a constant plus 2 meters per second square. So this is the graph of the acceleration, a constant horizontal line. Let's say this is 1 second, this is 2, this is 3, and so on. Okay, what I'm saying in this box over here is that to find the change in the velocity, you need to find the area under the acceleration time graph. In this case, I'm interested in the motion from 0 to 2 seconds. So I go from here to 2. This is my graph, and then to find the change in velocity, I need to find this area right here. So what this is telling me is that the area under this graph should be equal to the change in velocity. Now, what is this area, the area under this graph? I have a side of 2 and another side of 2. So this is a very simple calculation. 2 by 2, 4. I get 4 meters per second. This is the change in the velocity in the x direction. So anytime you want to find the change in velocity, if you have the acceleration versus time graph, then you can simply find the area under the graph, and this will give you the change in velocity. Now, this was a simple example. It was a simple area to calculate. You may not have a square, you may not have a rectangle, it may be a triangle, but the idea is the same. Again, you calculate the area using the area for a triangle, and whatever number you get, that is equal to your change in velocity. And as I said in the previous video, if you happen to have a graph, let's say I have, this is time, this is the acceleration. If you happen to have a graph that is, if this is the 0, if your graph is like, let's continue this. So we're here. If your graph is on the negative, in the negative value, so let's say I had something like this. I had an acceleration of not +2, but instead I had an acceleration of -2 meters per second squared. And this was 1, and this was 2 seconds, and so on. Then we will be finding this area. And now this area is going to be a negative number because we are below the 0. So the area in this case will be -2 times 2 is going to be a -4 meters per second. And then our change in velocity would be simply -4 instead of the +4. So anytime you're below the 0 axis, you will be finding a negative value for the area.